Okay, so before we start, I just want to say one way to look at this is like super distributive property, multiplying binomials. Something else I need you to hear from me is that in another section or so, we are going to be doing the exact opposite, so the reverse of it. So I think it's 8.5, because 8.4 is special cases of these. So you have to pay special attention to that, because I'm going to expect you to be able to reverse the process. Not only can you multiply binomials, but I'm going to expect you to be able to factor binomials. Again, that's 8.5, and we'll talk about that later. But so pay special attention so you get an idea of what the reverse process might look like. So we're going to, one video for the whole thing, we'll start out with what's called the FOIL method. FOIL stands for first, outer, inner, last. Technically, you can move these around. You call it LOIF, FLOI, whatever, but it's distributive property twice. Let me show you an example of what this really looks like. So if we were to look at the following, again, remember binomials like, oops, hang on, let me switch here to a pen. Remember a binomial is something like this, x plus 2. And we're going to multiply by another binomial, let's say x plus 3. And the FOIL method, first terms. That means I'm going to take these first terms, x and x, and we're going to multiply them together. So x times x, are you with me, is x squared. Outer, that means I'm going to take this term and this term, they're the outside terms, and that is x times 3 is 3x. Notice I'm using that positive in front here. That's a positive 3 and a positive x to get 3x. Inner, this term and this term are the inner terms. 2 times x, so that's plus 2x. Finally, last, 2 times 3, the last terms, which is 6. This is the FOIL method. We go back, obviously, and combine like terms. X squared has no like terms. 3x and 2x become 6x. And then finally, plus 6 at the end. So this is the FOIL method. You know what? 3x and 2x sure as heck aren't 6x, are they? They are 5x. Oh my goodness. So there you go. Again, FOIL method is what it's called. First, outer, inner, last. We're going to practice the heck out of this. Don't worry about it if you didn't get it from this short example. And I should note, what we'll do in 8.5 is I'm going to give you a statement like this and expect you to know that it is actually this when it's factored. So you're going to do the reverse. Right now we're just going this direction, but in 2 sections we're going to reverse that, and you're going to have to tell me, hey, x squared plus 5x plus 6 is actually the two binomials, x plus 2 times x plus 3. So you can kind of see here what that really looks like. First terms, right, a and c. Outer terms, a and d. Inner terms, b and c. Last terms, b and d. And again, multiplied out. What that looks like. First terms are a, c. Outer terms are a, d. Inner terms are b, c. Last terms are b, d. And generally speaking, these two terms will be ones you'll combine. So, but the last example is obviously more like what we're doing. This is sort of a generic algebra version here. One more look at it with the example from your book. And this uses another method, just kind of the idea of showing, okay, so I've got here x plus 2, right, on the side. And over here, 2x plus 1. So this one is here and this is here. You're going to create a matrix. And you write everything out and multiply it out. Personally, not been the biggest fan of this, but when you're done, you can see it. You've got 2x squared, so x squared, there's 2 of those. There's 1, 2, 3, 4, 5 x's, and then the 1, 2. This would be like if we were using the model using algebra tiles. This is what it would end up looking like. Your book likes to go through several different versions of how to do this using the distributive property, right? So taking your 2x times this whole thing and your 4 times the whole thing. That's really what you're doing if you take a look here. So again, this 2x plus 4 times 3x minus 7, that's the same as taking 2x times these guys and 4 times these guys. And you can see we're distributed here. Run those through, Combine like terms, and we get this. Again, I prefer just to jump straight to FOIL. It's up to you on how you want to do it. I'm going to do this one with FOIL method, though. Again, as a reminder, FOIL is first, outer, inner, last. So I'm going to start with this one. We have x minus 6 times 4x plus 3. And I'll start with my first terms, x and 4x. I multiply those and get 4x squared. My outer terms, so those are here, x and 3x. So I get 3x. Notice the positive in front. Inner terms, that's my 6 and my 4x. Notice that's a negative 6, so I get minus 24x. And then my last terms, we get negative 6 and positive 3, and that gives us minus 18. Then we go back and combine like terms. Nothing combines with the 4x squared all by himself. 3x minus 24x is minus 21x. And then nobody combines with the minus 18, and we're done. So I use the FOIL method. Your book talks about distributive method if you want to. You may use what you wish, but I recommend this one. It will be more useful when we do more advanced ones. Alrighty, so again, another method is to use the table method here. And this method is actually good in reverse for factoring. And we'll talk about that later. Again, that's like going from this version, the 4x squared minus 17x plus 15, and turning it back into the pair of binomials. Again, multiplying it all, so you can see the example they do here. They take their 4x minus 5, put it here, x minus 3 here, and then multiply everybody. 4x times x, so fill in the grid, gives you x squared, 4x squared. Negative 5 times x is negative 5x. 4x times negative 3 is negative 12x. 5 times negative 3 is a positive 15. Then you write your factors out. 4x squared minus 5x minus 12x plus 15. Combine like terms, and 4x squared minus 17 plus 15. So again, the table method's another way to do it. Again, I'm sticking to that FOIL method. I'm going to show you FOIL again on this one. Okay, and we're going to take this 3x plus 1 times x plus 4. And again, I'm going to start with those first terms. 3x times x. So 3x times x is 3x squared. My outer terms, 3x and 4. Notice it's positive 4. 3x times 4 is 12x. My inner terms, 1 and x. 1 times x is 1x, or just x if you prefer. And my last terms, 1 times 4. 1 times 4 is 4. I don't know why I wrote that in blue. So let's go back here, and we're going to have 3x squared. He doesn't combine with anybody. 12x and 1x becomes 13x. And then 4 is by himself, so plus 4. And that is the answer of this multiplied out. Again, I used the FOIL method. Please remember, again, in 2 sections, I'm going to give you something like this and make you turn it back into this. So be thinking about that, and this is where that grid method actually kind of helps you play with the numbers and figure that out. So here we go, officially using the FOIL method. So again, we can see here 5x minus 3 times 2x plus 1. And we can see the first terms, the 5 and the 2x becomes 10x squared, or 5x and 2x rather, becomes 10x squared. The outer, the 5x times the 1 becomes 5x. The inner, the negative 3x times the negative 3 times 2x is 6x. Notice the minus sign. And the last terms, negative 3 times 1 is minus 3. Combine like terms. 5x minus 6x is just minus 1x. And there we go. I'm going to do A on this slide, then I'll do B and C on the next one. So let's take a look here. We're going to start out A with 3x minus 4 times x plus 2. And again, my first terms here, 3x and x becomes 3x squared when multiplied. My outer terms, 3x and 2, when they multiply, becomes 6x. My inner terms, negative 4 and x become minus 4x. And my last terms, negative 4 times 2, becomes minus 8. And here again, we have those two middle terms that are like, so I'm going to combine them. So we're going to get 3x squared plus 2x, because negative 6 minus 4x, negative 6x minus 4x. Start that over. 6x minus 4x is 2x. There we go. And then minus 8 doesn't combine with anybody, so there we go. Let's take a look at b here. We're going to multiply the first terms here. And I'm not going to rewrite it. You can see it up there. N times 4n is 4n squared. Outer, that is n times negative 7 is negative 7n. Inner terms, negative 6 times 4n is minus 24n. And the last terms, negative 6 times negative 7 is a positive 42. So we go back and we take a look and combine like terms here. So first off, obviously 4n squared doesn't combine with anybody. Negative 7n minus 24n is negative 31n. And then just bring along the plus 42 for the fun of it. So there's B for you. And let's take a look at C here just a second. So C, now this one's going to be a little different. It's going to multiply the same way, but in the end it's going to come out a little different. So we start with the first terms. 2p squared times 2p is 4p cubed. So that's the first terms. Outer terms, 2p squared times negative 5 is negative 10p squared. Inner terms, 3 times 2p is 6p. In the last terms, 3 times negative 5 is negative 15. You go back and look. There are no like terms to combine here. I can't combine the 10p squared and the 6p because they have different exponents here, so I can't add them. So this is the answer for C, and we're done there. And just like everything else, I can find a way to make it even more fun for you. So applying multiplication of binomials. So a cylinder has the dimensions shown in the diagram. Which polynomial in standard form best describes the total surface area of the cylinder? So again, we've got to remember surface area cylinder in this case. We have 2 pi r squared, right? That's the top and bottom circle, plus pi radius height, 2 pi radius height, I'm sorry. I always call it pi diameter height. That's the surface of the lateral area. So that's the rectangle that makes them up. So if you don't remember what that looks like, by the way, if you were to flatten out this cylinder, you'd have the rectangle around the middle that makes up like the label of the can, right? And then you've got the circle on top and the circle on the bottom. So 2 circles and a rectangle, and this is the formula for that. You learned that last year. But again, going back here, we plug in what we do know. Well, we know there's an x plus 1 for the radius, and the height is apparently x plus 4. So we plug those in. Plug in for radius, x plus 1, right here. Plug in for radius again, x plus 1. Plug in for height, x plus 4. Now we can see here we're just going to distribute the 2 pi here. Actually, you had x plus 1 times x plus 1. Write that out, and then multiply those out. And then multiply out what we just learned again, x plus 1 times x plus 4. Multiply those out. Then we can go back and we can go ahead and sort of undistribute, right? 2 pi and 2 pi times that. Well, you pull out the 2 pi, add everything up inside, right? Then go back and distribute. Now, you could have distributed the 2 pi first and then combine like terms if you wished. Either way, you still get to the same answer. Lots of algebra really happening here. I really like this. But again, we use what we just learned, multiplying binomials here and here, along with stuff we learned last year, a formula, and did lots of algebra fun with it. So we're going to do the same thing again. So this time we're going to change numbers a little bit just to give you that algebra fun experience. So I'm going to draw you a pretty picture here. It says, so we have a cylinder again, right? And it says this time the radius is going to be x plus 2, and the height is going to be x plus 4. So the height part didn't change, but the radius did. And again, back to that formula. Surface area of a cylinder is 2 pi r squared plus 2 pi RH. This is literally just plug it in and do the algebra. Don't lose your way. I'm going to go slow for you. So we have 2 pi, the radius is x plus 2, so x plus 2, the whole thing squared, plus 2 pi, radius again is x plus 2, the height is x plus 4. Now I'm going to expand this a little bit on the x plus 2 squared. So 2 pi times x plus 2 times x plus 2 plus 2 pi times x plus 2, it's a 2 I promise, times x plus 4. I know it looks like a lot, one little piece at a time. Let's go ahead and FOIL, right, or multiply out this part. So the 2 pi comes along for a ride. We're going to multiply that out. What that's going to look like is going to be, I'm going to leave it in parentheses for you, x squared, right, plus 2x plus 2x, so outer, inner, and last, so plus 4. And if you're not sure of that, go back and multiply it out. Now, let's go back and let's do the second one before we do anything else. So plus 2 pi, and again, first is x squared, so x times x, outer, so 4x, inner is 2x, and last becomes 8. If you need to pause there to go back and check that, do that. Let's go back and combine some like terms on these guys. So 2 pi times, this becomes x squared plus 4x plus 4. The other one becomes plus 2 pi times x squared plus 6x plus 8. And we can see here we can pull out this 2 pi, right? And everything else just gets added together then. So we've got 2 pi times, let's write everything in there, x squared plus 4x plus 4 plus x squared plus 6x plus 8. So that's all the guys from here and here. Now we combine like terms. 2 pi times, well, 1x squared and 1x squared is 2x squared. And 4x and 6x is 10x. And 4 plus 8 is 12. Almost there. Now I just need to distribute that 2 pi. Just a second. So that becomes 2 pi times 2x squared is 4 pi x squared. Remember, the pi comes first because it's actually a number, not a variable. 2 pi times 10x is plus 20 pi x, and 2 pi times 12 is 24 pi. And that's it. I know it looks like a lot. It's kind of fun, I think, though, because you got a lot of algebra going on. Got to keep a lot of things straight here. If you weren't sure on that one, pause, rewind, back up, look at it again. Follow step by step. Alrighty, so here we can also multiply trinomials and binomials. So if you take a look at the answer, or the example here, 3x squared plus x minus 5 times 2x minus 7. Now here we set it up kind of like regular good old-fashioned multiplication, right? The negative 7 times everybody, the 2 times everybody, right? Line them up and then combine like terms as you go down. So let's make sure we understand that. Negative 7 times negative 5 is positive 35. Negative 7 times x is negative 7x. Negative 7 times 3x squared is negative 21x. Leave a space holder just like real multiplication. We do like 3 by 2 multiplication. 2x times negative 5 is negative 10x. 2x times x is 2x squared. 2x times 3x squared is 6x cubed. Then add straight down. And that's what we get. And you can't combine any like terms along here. And that's the product. Now, for the I'm going to do the next slide. It says, what is a simpler form of this, and how can you use distributive property to find the product? I'm actually going to do it using distributive property, so I'll show you that on the next slide. Okay, so we've got the 2x squared minus 3x plus 1 times x minus 3. And I'm going to take this x minus 3 here, and I'm going to divide it up and multiply each one times the whole set. So what that looks like is I've got x times, and that's 2x squared minus 3x plus 1, and I've got negative 3 times, again, that's 2x squared minus 3x plus 1. So again, notice here, we've got the x minus 3 here and here, and this same set, and we're just going to basically distribute twice. So The first one looks like this. We get, let's see here. So we get started out. So we've got 2x cubed. So again, x times 2x squared is 2x cubed minus 3x squared. So that's x times negative 3x. And then x times 1 is plus x. Then, again, by the way, don't lose your negative in front here. So we've got negative 3x times 2x squared is minus 6x squared. Negative 3x times negative 3 is plus 9x. There we go. And negative 3 times 1 is minus 3. Now we've got like terms here. Nobody's like the 2x cubed, so that's just going to come down on its own. It's a cube there, not squared. Alrighty. And then I have minus 3x squared minus 6x squared is minus 9x squared. And then we have plus x plus 9x is plus 10x. And then just minus 3 all on its own. And there are no more like terms combined, and there it is. So that kind of answers B as well, because again, I'll use distributive property on it instead of the whole lining up thing. So there you go.